Hi class, welcome to lesson 4.4b. This is the second part of lesson 4.4. Today we are going to continue factoring, but this time we're going to look at special trinomials because they're going to be a fourth degree polynomial, and we're also going to look at some special cubes that we can factor. So I'll show you the tricks to getting these factors done correctly, okay? So have your notes ready to go. Here we go. Starting at example 2, it says fourth degree polynomial. Now, how do I know it is the special one? So I see a 4 and then a 2 and then a nothing. So when you see this pattern, think about it. It doesn't always work, but it sometimes works. When you do see this, we're going to try using a trinomial where we have the a, b, and x. A, b, and c. And we're going to start with x squared times x squared because that gives us our perfect x to the fourth power. Next, we're going to brainstorm just like our trinomials. We're going to put a times c on top. So 1 times 33 goes on top, and our b value goes on the bottom. So think 33. What times what is 33? That if you add these up, you'll get a 14. And I see a lot of 3 staring in my face, so 3 times 11, thank goodness, does add up to 14. So those are my two magic numbers. Positive 3 and positive 11 will give me that positive 14. So I'm going to put those two numbers here, positive 3 and positive 11, and I'm done factoring. So sometimes you want to look at these special trinomials where it's 4, 2, nothing, and that's how you can factor. All right, let's try this one right here. And I see a 4, 2, and nothing in looking. So I'm going to start just like this trinomials. You want to think factors of 9 here that will add up to 10. Now, I know 3 times 3 makes 9, but if I add 3 times 3, that's only 6. So 9 times 1 would actually give me 10. So those are my two numbers, 9 and 1. And notice I do need a negative 10. So I'm going to use a negative 9 and a negative 1. Because a negative times a negative will give me that positive 9. And if I add them up, it will give me a negative 10. Now, this one's a little tricky, so if you could put a star on this one. Over on the first one, example 2a, we're done. After this, there's nothing else you can do. You can't factor anymore. These are a little bit more special. If you look at only the first factor alone, which is this first group, this is a negative sign. If this is a negative sign, those are the tricky special ones. 9 is a perfect square because 3 times 3 will give me a perfect 9, and 1 times 1 is a perfect 1. So this one you can factor one more time. Isn't that so tricky? This is something you already did a lot of factoring in Algebra 2 Part 1 last semester. You can factor this to a negative 3 and a positive 3. Remember, you can write positive 3 first and then a negative. Now, careful here as well. 1 times 1 is also 1. So, yep, you can factor that one more time. So 1 is a positive, 1 is a negative. Make sure they are opposites. So how do I know when to do this? When you look inside in the group and you see x squared, especially when it's a negative, it won't work if it's a positive. But if it is a negative, and this is a perfect square, things are perfect, like 1 times 1 is 1. If it's a 4, because 2 times 2 is 4. This one is 3 times 3. So look for those perfect numbers. If it's perfect and a minus sign, then yeah, you can write it factored one more time. The directions will tell you to factor completely. Okay? All right, let's try a few more of these. These are all to the fourth power. So if you want to pause the video and try them all and see how many of these you can get correct. And when you're ready to check, replay the video to check your work. All right, I hope you got a chance to check it. So here's letter C. Yeah, I see a 4, 2, nothing. So I'm going to try it just like a trinomial. Positive 9 and negative 4 will guarantee that positive 5. And because they're opposites, I get that negative 36. Again, remember I just said check those perfect numbers? 9 is perfect 3 times 3, but that's not a negative sign. How about this right here? 4 is a perfect number. 2 times 2 will give me that perfect 4. And this is negative. So I can rewrite that second factor into 2 more factors. And that right there is your final answer. So when I say factor completely, this would be a completed factored form. Okay? All right, if you didn't get a chance to try the others, please pause the video and try it. Let's check letter D. I need factors of 21. Not too many numbers go to 21. I know 3 times 7 would do. And thank goodness 7 times 3, or 7 take away 3 is 4. So that would work. Keep the negative with the bigger one to match that -4. So this is squared, but 7 is not so perfect. And that one's not negative, so I am done. This is factored for this quartic. All right, take a look at this. Again, do the X and brainstorm if you need to. There's lots of numbers that make it 36. 1 times 36, 2 times 18. Start brainstorming a lot of them, okay? And in this case, 6 times 6 will give me a perfect 36 that adds up to 12. So our goal is to add up to 12. And these are both positive, so I'm done. Okay? Now this one's strange. I don't have a middle term. See how it's 4, 2, nothing, 4, 2, nothing. Well, it is okay to factor where there's nothing in the middle, just like this. But you do want to make sure the middle term cancels out. Those are opposites and those are conjugates. The middle term will cancel. So that's our goal for 16 as well. 4 times 4 will give me that perfect 16. And because they're perfect opposites, the middle terms will cancel. All right, ooh, gotta be careful. This one's a minus sign, and 4 is a perfect square. So we're gonna split this, just like we did up here. So this is split into a -2 and a +2. Okay, keep that x squared plus 4. Do not touch that one. That right there is already factored. So this is factored completely. All right, so start recognizing this. Try it whenever you can. You see the x to the 4th. Sometimes it works, sometimes it doesn't, but this is a very good way of factoring. All right, we're going to add one more strategy. This is totally new and different, but an easy pattern to remember. So the polynomial has 2 terms. So this is a special polynomial where it has 2 terms, and both terms are actually perfect cubes. And this formula will be given to you so that you can refer back to it. Make sure you have this in a nice safe spot so that you can refer back to it when you do your homework and your quiz and your test. So it's something cubed plus something cubed. When you do see this, there's only 2 terms, it follows this pattern and you're done. Once you set this up, it's a small group and a big group and you're done. So let me show you a couple examples of how this is set up. Okay? All right, so it's a third power. Let's check it out. So first thing to start is, how can I rewrite it as something cubed and something cubed? So you think, what times what times what? So 3 numbers multiplied. 3 same numbers multiplied to give me 8. And that is 2. 2 times 2 times 2 is 8. Keep that side in the middle to match. So that side right there stays to match. All right, I'm going to rewrite this formula again. You're welcome to rewrite. I suggest you do it as well so that you can replace anywhere you want. So inside the first parentheses representing my A, inside the second parentheses representing my B, and I'll show you how to fill this in. Okay? All right, for the first small group, you're going to match what you see up here, just the inside. So it's x, keep that -2. So the first group is x minus 2. Just keep it. All right, we're ready for this big one. Give me a big parenthesis. In the front is the first thing times itself. So x times x goes here, so that's x squared. I'm going to jump all the way to the back. It says b times b. 2 times 2 is 4. So back here is going to be 4. In the middle, well, it's these 2 multiplied. So it's x times 2. I'm going to show you how to fill in the symbols, okay? So x times 2 is 2x. And let me tell you about the relationship. Why did I make this a red symbol? The first group matches the original problem. This second symbol is always the opposite of what you see in the front. That's it. And back here is always going to be a plus sign. So keep it a plus sign, okay? That does not change, okay? All right, let's try a few more. This one is something cubed. So you want what times what gives you 27. 3 cubed is 27. Again, follow the same pattern. Write it out if you need to. And the first parenthesis matches. So x minus 3 is the match. Ready? For the second big group is the first thing times itself. Back here is the last thing times itself. So 3 times 3 goes here, which is 9. In the middle are those 2 multiplied. So x times 3, I'm going to put 3x in the middle. Okay? And then for the signs, this is always the opposite of what you see here. And back here is always a positive. Okay? Follow the pattern and you'll do fine. All right, the next few numbers have pretty large numbers, just the same pattern variety, but with different numbers, okay? All right, so this is 216. Instead of sitting and guessing, you can use in your calculator. If you go to Desmos, if you want, you can find the cube root of 216 instead of guessing and checking. So this one is actually 6 times 6 times 6, or 6 cubed is 216 exactly, okay? So following that same pattern, the first group will be what you see. So it's going to be x plus 6. Remember, you match the symbol that's already there in the first part, okay? And then over here is where you do the opposite symbol. See, this is an opposite now. All right, the first part is x times x. The second part is 6 times 6, which is 36. And the middle are these two multiplied, x times 6, which is 6x. All right, and this first symbol is the opposite of what you see in the front. And back here is always positive. All right, pause the video. There's 3 more for you to try. See how you do, and then you can recheck, try the video when you're ready to check. All right, letter D. Did you find the cube root of 1,000? It really is 10 cubed. 10 to the third power is 1,000. Okay, the first group should match x plus 10. And the second group, did you square the front? Did you do 10 times 10 in the back? And the middle, did you squeeze these two numbers together? So it's 10x in the middle. You check that negative sign for me. Is this the opposite symbol of what you have here? All right, how did you do? All right, let's check 2 more. Let's see what you did. Yeah, try to use your calculator. Hit cube root. So you want to do 3 and then the little cube root sign, square root sign, but with the little x on it. So you get cube root of x. Use Desmos. You can type in the radical sign. Okay, so instead of guessing and checking, but this one, it really is 7 cubed. All right, first group says the same, so I should see x minus 7 in the front. All right, let's square it. First thing squared, so x times x is x squared. Back here, 7 times 7. Do you have a 49? And the middle, squeeze those two together, 7x. All right, last one. Let's see, did you find the magical number? It was 4. 4 to the third power. All right, so first group is going to match. Keep the plus sign. X plus 4. All right. Do you have x squared in the front? 4 times 4, which is 16 in the back. And squeeze the middle together. All right, that is the end of our lesson. Go ahead, try the homework, see how you do, and re-watch the video if you need some hints.